So our goal is to find the size of the tree that minimizes the error rate on independent data. Okay, and in the previous lecture, we saw a way by which we might be able to do this, but we found that that compromises the independence of test data. Right? So to avoid this problem, classification tree methods, automated methods, they use a process called cross-validation. Okay, so let's take a look at that approach. So in cross-validation, what happens is that, as usual, you divide the data into training and test, which is what we do, and then we build the tree on the training data, right? But what they do is they creatively use the training data to generate the error rate chart that we saw earlier, right? And that is in the test data, the error rate goes down and then starts going up. They have a creative way by which they can generate the chart without dipping into the test data at all, right? Which means that our test data will remain independent. And once we have built the model, we can always go to the test data and evaluate the model, right? So without corrupting the integrity of the test data, we will still be able to perform this process. And that is what is cross-validation. Okay, so in cross-validation, what we do is we take the computer does this, is it takes the training data and divides it into certain equal number of, certain number of bins containing equal numbers of cases. So let's assume that it's going to take the training data and divide it into 10 equal parts. In other words, let's say I've got a training data set that contains 1,000 rows. Then it'll divide it up into 10 sets of 100 rows each. Okay, so that's what it's going to do. It's going to first divide it up like this, right? So now the training data has been randomly divided into 10 equal parts. Okay, it could be 10, it could be 20. I'm just using 10 as an example, and this is what our part uses by default. Okay, so once it does that, then what it's going to do is it's going to take the training data itself and divide it into two parts. Okay, so for example, it'll take the first 9 sets as one block and leave the 10th set as a separate block. Okay, so for example, if our training partition contained 1,000 rows, right, then each of these is going to be 100 rows. So it's going to treat these 900 rows as one set, and it's going to treat these 100 rows as a separate set. So internally, it is going to keep this 10th set out as a test partition. Okay, this is not our test partition. Our test partition is completely separate. But within the training itself, it's going to put away some data, and it's going to build a model using only the remaining. So in this example, it'll build a model using these 900 rows, let's say, right? And once it builds the model with these 900 rows, it'll test it with these remaining 100 rows, which were not used for model building at all. Okay, so that is an independent test. It's doing that independent test without actually getting into our real test data, the test partition. Okay, so it does this. It's going to treat that as training. It's going to treat this as what is called as a validation partition. And on this set of, let's say, 900 rows, it's going to, of course, build trees of different sizes, just as we saw, because in the process of splitting, it's going to have trees of different sizes. So initially, it's got a tree with a root node alone from these 900 cases, right? So it can take that tree, run it through the test partition, the 10th one, which is the validation partition, run it through the validation partition and compute the error rate. Okay, so it's going to compute the error rate on the validation data for that's the initial tree size, the root, which is the tree size of 1. Then it's going to do the first split, again compute the error rate on this. Second split, again compute the error rate, and so on and so on and so on, up to the maximum size of the tree, right? So what is going to happen is that for this setup, which is these 9 sets as training and this 1 set as validation, it's going to get the error on the validation set, which is on this set, for 10 different tree sizes. Okay, and that is on this configuration of 1 to 9 as training, 10 as test. So for that, with the tree size of 1, this was the error. For a tree size of 2, this was the error, and so on. It's going to get that. Let's call that whole set as result 1. Then what it's going to do is it's going to treat 1 through 8 plus 10 as the training and 9 as the validation. Okay, so every time what it's going to do is it's going to leave out one of these 10, keep it as validation, use the remaining 9 as training. Okay, so once again it's going to do the same process of building trees of every size, and for every tree size find the error on the validation data. Okay, let's call that as result 2. Okay, then comes result 3, where it's going to keep out 8 and use the remaining as training, and again it's going to get result 3. Okay, so in this process we can clearly see if there are 10 divisions of the training set, you're going to get 10 such results. Okay, that is, for every tree size, for a tree size of 1, I'm going to get 10 different errors on the validation, right? Depending on which set is being used. Okay, and finally it's going to get this. That will be result number 10. That is, 1 is kept as validation, 2 through 10 are used as training. Of course, this validation shouldn't be here. This validation should be up there. Okay, so that's what you're going to get. So what you're going to have is all the results from 1 through 10, and we are going to get that as, for a tree size of n of 1, we're going to have, we had 10 different values, right? From result 1, result 2, result 3. So for each tree size, we had 10 different values. So you can calculate the mean error on the validation. Okay, so that's what you're going to get. You're going to get this plot based on this. These are the 10 values, and let's assume some numbers for them. I have not shown them. So you're going to get the tree size, and you're going to get at what size of tree was this error minimum, right? Because if there's any overfitting, that is going to show up in this tree as well, because we are putting aside some of the data as independent data for validation. So this is indeed an ingenious idea, to be able to generate this error chart, or how the error changes with different tree sizes, without really tapping into the test partition at all. Okay, so the whole process is now going to be that you first build your complete tree on the training data, right? And you now know, based on the chart that we generated on the previous slide, we know what is our optimal tree size, right? So now we prune the tree back to that optimal size. Okay, so we prune the tree back to the optimal size, and that is the pruned tree. And it is the pruned tree that we'll be using, which will typically be smaller than the full tree. So that ends the model building phase, right? So this is the model building phase, building the full tree and pruning it back. Now that we have the model, we need to now truly test the model. And we test the model by applying the pruned tree to the test data, right? So we've got the test data, we apply the pruned tree, and we see the performance of this model on the test data. Okay, if we like the performance of the model on the test data, we can then deploy the model, use it on a regular basis. If we don't, of course, then we have to go back to the drawing board and build a different model.